Calculus, let's grade this mastery check. Good to see you. So I want you to really try and get used to, in this unit specifically, moving back and forth between interpreting f, the function, and f prime, the derivative. So you took notes on f prime, critical points are when f prime is 0 or undefined. We have to now look at this graph, and instead of looking at the slope, we say, hey, this is f prime. Where is this graph 0 or undefined? Well, here's one, here's another, and then here's a third. So those first two are the places where the graph, the graph of f prime is 0 when it crosses the x-axis. And the third one is where the graph of f prime is undefined. That's different than if I would have given you the graph of f. So that's a little bit tricky, but for which x values, we can say x equals 1, 3, and 4. Explain? Well, at 1 and 3, f prime of x equals 0, and at 4, f prime of x is undefined. That's all you need. Look at number 2. It says, here is g of x. Find the critical point of g of x. Critical points. When is g prime of x 0 or undefined? Since this is a polynomial, it's never going to be undefined. So we don't have to worry about the undefined part. We just have to worry about when is the derivative equal to 0. So let's solve this thing. G prime of x equals 6x minus 8. And now we solve this for 0. So we say 0 equals 6x minus 8. Add 8 to both sides. Divide by 6 on both sides. We get 8/6 or 4/3. That is the one single critical point of this function g of x. Number 3, sketch a function that meets these requirements. An absolute max at the left endpoint. Let's start there. I'm just going to toss it down. Oh, wait. So this is from -3 to 8. Okay. So -3 all the way out to 8. I'm just going to toss a point way up here. That's going to be its max. Cross that one off. Relative minimums at -1 and at 3. So here's -1 and here's 3. And I know for a relative minimum, I need to just have a little dip there. So both of those places now, compared to the points around it, they are the lowest value, right? So that's a relative minimum. So cross that one off. Absolute minimum at x equals 6. Let's just toss this down. Here's 6. I got to go to my lowest point right there. I probably didn't have to go this far down, but for ease of reading this graph, now I know that's going to be the lowest point. And an undefined derivative at 4. Well, crap, now I got to redraw my function here. So I would say, no, here's the end point. But if I want the derivative to be undefined, 3 things have to occur. Number 1, it could be just a hole. I could say that the derivative doesn't exist because the function doesn't exist. Number 2, there could be a cusp. Or number 3, it could be a vertical tangent, right? So anything that makes it not differentiable means my derivative is undefined. So I'm going to erase this section. Here's 4. What if we just say, oh, rats. Didn't want to do that. What if we just say this is now a sharp point? And it can still get to its absolute minimum at 6. I honestly don't even have to go that far down. Is it still an absolute minimum at 6? Yeah, it's still the lowest point. Is my derivative undefined here? Yeah, it's a cusp. It's too sharp. It's not smooth. My roller coaster wouldn't work. So better erase this bottom chunk to make sure it's still a function. Your graph should look something like this. The left endpoint should be the highest part. 2 relative mins here and here. Absolute min right here. Some sort of cusp or vertical tangent or hole at 4. Last one, number 4. Hey, a function is continuous and differentiable. Those sure sound to me like the mean value theorem conditions. If f of -2 equals -5 and f of 1 equals 4, which could be false? Okay, so we're trying to figure out which one's false. If f of c equals 0, this looks like an IVT statement to me. So remember, IVT, we're thinking about outputs. MVT, we're thinking about slopes. So f of c equals 0, that's an output. Could there be an output of 0 between negative 5 and 4? Yeah, absolutely, 0 fits in there, sure. So C, sorry, I didn't want to erase that part. A is an IVT part, and it's definitely true. Let's look at the other IVTs. Could I cross 3? This is also an IVT question. Could I cross 3 between negative 5 and 4? Yeah, I got to cross 3 somewhere, so C can't be true either. Or sorry, C can't be false. It's definitely true. Now I got 2 more that look like MVTs, and then I have this weird one, E. Let's look at E. There exists a C between those two such that V of C is greater than or equal to V of X for all X on the interval. What does that even mean? So V of C greater than or equal to, sorry, F of C for all X on the interval. So it's saying, is there a maximum value where f of c is the maximum and is greater than all the other inputs? Yeah, that's our extreme value theorem. That's kind of what we learned about today. So this one definitely is true, so it can't be false. And these last two look like MVT, so let's see what's going on here. For MVT, we're always thinking average rate of change. So f of 1 minus f of negative 2 over 1 minus negative 2, and we get 4 minus negative 5 all over 1 minus negative 2, or 9 over 3, or just 3. So it sure looks to me like the slope of the secant line is 3, which means there's definitely a place where the slope of the tangent line is 3. So this one is true. It can't be false. The only one that could be false is this one, B. There might be a place where that slope equals 0, but we don't have that information. We can't tell from what we're given. So correct answer is B. This is a really common way to ask the MVT on the AP test. Your goal is to just to interpret this as best you can. And there's a lot going on here. So think about each of those possibilities. This one's tricky. If you have questions, ask someone around you, take a little bit here, try and figure that out. But go ahead, turn this in to your teacher whenever they ask for it. This is for a small P&P in-class grade, just to make sure we tried something here. Nice work, everybody. Have a good day.